My name is Dr. Alan Dennis. Today I'm going to talk with you a little bit about big data. So first, a little bit about me. My doctorate is in computer science from Colorado Technical University. I have a master's in computer science from West Virginia University. I have a lovely wife and 4 adult children and 3 grandchildren. My wife and I live on a 74-acre farm. We have way too many animals and way too much stuff to take care of. So the images on the bottom of the screen, the bottom left is Oliver, our munchkin cat who was watching TV with me. Next to that is our youngest daughter and 3 of the grandbabies and my wife on the right. I'm the guy in the funny hat in the middle. To my right is the youngest of our grandchildren at Christmas time, feeling a little bit overloaded with all of the stimulus. And then to the right of that is one of our horses. It's a miniature horse with my wife holding the reins. So moving to big data. So what is it and why do you care? Well, first, it kind of has some characteristics that we need to talk about. For example, what is it? What does it mean to be big data? And typically people talk about 3 V's, and they use those terms because the words start with V's. It's sort of a marketing thing, but it actually is a fairly accurate way to talk about it. And to be clear, things don't have to have all 3 of these. They may only have one, but typically there is some overlap between them. So if you think about velocity, that's how things move quickly, and that's a good indicator of a big data solution. So things with high velocity are things like Internet of Things, where you have data streaming from lots of sensors and it's coming very quickly and you have to process it in some fashion very quickly. Then there's also the whole big part, right? So things that are large, they have lots of volume. That's where you're dealing with not only could things potentially be being made very quickly, they may be very large. So that's where if you have something like a camera capturing images, that's an example of something that might produce something that's quite large, especially if you're capturing every frame that it produces. Multiply that by a large number of cameras and you end up getting an idea what big could mean. And then there's also this whole variety thing. So things come to you in different formats. Part of that comes because things kind of all talk together now. There was a time whenever things were much simpler where you had a standardized sort of format that something might arrive. Today, that's not really the case. Instead, you have things that come to you in lots of different varieties. So how did we get here? So it's important to understand kind of the background of things to get some sense as to why it is as it is. So if you take a look at in the early foundational area, I guess you would call it, in the 60s to 80s, we had some fundamental things we had to get figured out. First of all, we needed a computer. So personal computers kind of came to be in this time, and so did adoption of really kind of viable organizational type computers, even servers and such. So we start from nothing. You have these boxes that really don't know much about each other and so on. So your first thing is to get them hooked together. That's what ARPANET was about, was figuring out a way to create networks. And then also you had to get, once you get these networks, those networks need to talk to each other, right? So to do that, you need something like TCP/IP or some internet connection technology. And these are things that were being figured out. Usenet, early form of news, so that you could actually communicate textual information or even binary information with proper encoding over the internet. So that was a pretty big thing, a way of breaking out of the traditional news feed sort of world. Then this concept of a dial-up became important. So once you have these networks talking to each other, that doesn't help the average person unless that average person can afford to go out and pay for a connection to the internet. And that was quite expensive. So what people figured out how to do was to take these relatively low-cost modems and hook them into a network in such a way that your average person could connect to the internet. Then we needed a way of kind of starting to organize this ever-expanding set of things, and that's where things like domain names come to be. So you need a way of being able to find servers and services based upon something rather than what you would have to have used instead is a cryptic sort of set of numbers. So you could actually register a name, so your company name, and be able to find it by that. Today we take this stuff all for granted, but it was a big deal during the time. So then we move into the 90s, and that's when things started really happening. The key kind of milestone here is the creation of the web. So the World Wide Web and HTML, that's a big thing. Especially in the context of big data, because it started serving as kind of the source of data that's being generated, as to a large part, is coming from that sort of place. Then about adoption. So Windows 95 and Internet Explorer came out. Now, you may not like those things today, but at the time, it made it accessible and easy to use. You could relatively quickly get onto a network. Prior to that, it was very difficult to get like a Windows machine connected to an internet. It was challenging, or an Ethernet even. So a local network was somewhat challenging. Microsoft understood that the internet was going to be a big deal. So they pivoted and made it very well supported inside of their products. Also during the 90s, we had the launch of some companies now that pretty much dominate the industry. Amazon, Yahoo, eBay, Google, and then the creation of Java. It's also worth noting that Python actually was created back, in the 80s, the late 80s is when Python came to be. That's important from a big data perspective because that's one of the languages that is very frequently used. So moving into the 2000s, it was not all good. Right around 2000, we had the dot-com bubble. What had happened was that everybody thought the internet was going to be a big thing, so you could basically create a company on an idea, and if you're lucky, get bought by one of the larger companies for a lot of money. So that was the kind of philosophy of the time, and it wasn't viable. So eventually the bottom fell out and the stock prices basically tanked, and a lot of the internet companies had to actually start making money, the right way, through revenue, not just through perception. So Google also then took ownership of search. Basically, it started dominating search. Prior to that, there were other search engines that you could utilize, but Google's algorithm, using the PageRank ranking algorithm, was amazing. So it just took over. Also contributing to this creation of data is things like Wi-Fi. Prior to the adoption of Wi-Fi, you pretty much had to plug everything up, and that was really kind of challenging. So the connection between Wi-Fi, iPhone, is introducing the whole concept of this mobile internet, and that's a big deal because that basically is generating lots of data potentially through having always connected devices. You also saw the rise of things like cloud computing. So AWS was launched, and then some technologies that became important in the big data world over time, things like NoSQL and VMware. The biggest kind of, from a big data perspective, thing that happened was the introduction of Hadoop. And we'll talk more about Hadoop in a little bit, but the key thing here is that it was a way to cheaply process lots of data because that data was coming from somewhere and needed to be dealt with. So moving into the 2010s, we had fast networks come in, so 100 plus gigabit Ethernets. We had the kind of a standardization around virtualization with Docker. There's lots of cloud hosting data centers that were spun up and created. And also from a big data perspective, really important, Spark was introduced. And Spark kind of goes hand in hand with Hadoop as a processing sort of approach. And we'll talk a little bit more about that later. But it was a key sort of milestone that all of a sudden we now had another framework that we could use whenever we're talking about processing data. Moving into the 2020s, yes, it's really early in this game as I'm recording this, but we're already seeing some trends. Edge computing is becoming very powerful and very compelling. Edge computing is basically where you have the Internet of Things or something like that. So you have lots of little devices, or maybe not so little devices, connected to the network, sending data or interacting with devices like a machine or a processing machine or a manufacturing device of some sort. What edge computing does is moves processing down to the place where the data is being captured, or as close to it as it can get. Alternative to that is to do the processing in the cloud. That means you have to transmit all the data. One of the characteristics of big data is not all of the data is all that valuable, and some of it that is valuable is only valuable for a very brief amount of time. So doing that computation closer to the device reduces the amount of things that have to be transferred. You could only transfer those things you care about, not everything that you see. And then also one of the trends we're seeing is a lot of adoption around artificial intelligence and AI. It's kind of somewhat going in parallel with edge computing, because one of the things you might do in an edge device is some sort of anomaly detection, or some sort of prediction, or like end of life sort of predictions around the device that you're talking to. So they all kind of weave together. And obviously a whole lot more to come. and we'll see it over the next few years. So why did big data come to be? It's a pretty important concept. Why are we here? Why did it even think? We saw the timeline, we saw all the things that are being created, but why did it happen? And one of the key things is that the internet changed from being about a bunch of content providers. So a company would go out and they'd create a website that says, hey, I'm some big manufacturing company and here are my products and here's how you can go look about them, basically replacing the brochure sort of mentality. And it shifted from that to enabling the creation of content. So you had things like Facebook and the various other YouTube and so on, places that they didn't actually build the content. They just built the system that let the users build the content. And because they do that, you have reduced the bottleneck of how that content comes to be. If a company is making their own content, it takes a lot of time and a lot of money, so they don't make as much of it. If you have a bunch of people, literally millions of people, connecting to something like YouTube and uploading their videos, there's really no limit on how much data can be produced. It's just simply the amount of users times the amount that the company lets them store. We also saw this kind of emergence of software as a service over time. And what that means is that the application, say like email, is hosted inside of the cloud. And so that you can then utilize it without any sort of installation on your computer. And what that means is that all that data then must reside in the cloud. And so it also allows the potential capture of additional data, such as what you're doing, how you click on things and so on, how you use the site. So that also produced a fair amount of information. One of the bigger kind of initial drivers anyway was log files. So whenever you have all these web servers out there running, even in the time whenever it was just content providers, you want to know what people are doing on your site. So one of the initial uses of things like Hadoop and MapReduce was to analyze log files. And that's why part of why the adoption became very clear. And so people had the need to, hey, we've got these huge files, we can't process them normally as we've always done in the past, so we need to do something different. And that's where things kind of drove the creation of some of these tools. We also have now lots of devices producing data. In fact, devices produce more data on the internet than people do. So it's become where you have to have some means of doing something with it and doing it relatively quickly and efficiently. And one of the other kind of adoption reasons is that computers can only get so big and so fast. We reached a threshold where clock speed stopped going up because it got too hot, and we started becoming limited by things like the speed of light. And so rather than keep shoving computer processors into the same box, the idea is to go wide instead of big. What that means is have lots of relatively small boxes talking together in an intelligent way, rather than one big, huge box that's doing all the work. So how is it done? Because okay, we kind of see what we need. So how do you make it happen? And it all comes down to low-cost servers and fast networks. It's about creating these networks of clusters of worker nodes essentially, and then having algorithms that plan on them to fail periodically because they are inexpensive. They don't have necessarily the same life as perhaps a more expensive piece of equipment. So hard drives are going to die, processors are going to blow up or whatever, melt. So bad things will happen. So the algorithm has to handle the case that it's going to fail. Also, it was a real pain to write distributed algorithms early on. And that's where the concept of using something like MapReduce, which is basically where you have a developer essentially write two functions basically. And it makes it much simpler because rather than them having to figure out how to split everything out across lots of different workers and how to pull it back together and how to make sure everybody has the right data that they need access to and all that stuff, there's an algorithm that basically says, hey, write your code here and here, we'll take care of the heavy lifting. And that's really part of what drove the adoption. Was it made it to where it was much more attainable for somebody to implement. And then one of the other kind of key elements here, and it's becoming more important over time, is around cloud hosting of these low-cost servers, and more than just cloud hosting of them, actually instrumenting them and controlling them and creating them and destroying them and managing them all within the cloud, so that a person doesn't have to go out and buy 1,000 computers and plug them up together. they go on to their favorite cloud hosting provider, AWS, Google, Azure, and basically say, hey, I want a cluster with a bunch of nodes. And if you got the money to pay for it, you can get the nodes. So the other key piece of that, because it is in the cloud, is that once you're done, you can turn them off and delete it. To where if you do it in a physical world without cloud computing, you're going to have some hardware to deal with after the fact. So that's one of the key pieces that is making the combination of big data and the cloud so compelling, is around elasticity, the fact that you can expand and contract as needed depending on your workloads. So we've talked about a lot, and we talked a little bit of a history about how we got here. Now, it's the references that were on the earlier slide. If you really want to go and dig into the history of computing and the internet, feel free. It is very compelling and interesting, and sometimes we forget how we got here and what it was like in early days. We talked a little bit about why big data exists, and we talked a little bit of how it works in a very simple way. And with that, I say thank you, and I will speak with you later.